Good afternoon. Everybody get some lunch? Rested? Full bellies? Well, good afternoon. My name is Neil Rothletter. I am with AWS Professional Services in our Security, Compliance, and Risk organization. I run a small team that focuses on the fusion of technologies like AI, machine learning, and formal methods with security. In just a few minutes, I'm going to ask the stars of our show to come up, and the majority of our time they will lead. Tim Kropp and Greg Frescador from Bridgewater Associates. We're really lucky to have them here. I'm going to ask you just right now to please thank them for being here. It takes time, and give them a little applause. Thank you. So before they get going, I wanted to take just a few minutes, 5 minutes or so, to tell you about some of the concepts and the technologies that Tim and Greg are going to talk about today. The first is the AWS shared responsibility model. For those of you that aren't familiar with it, the key idea is that security and compliance in the cloud is a shared responsibility between AWS and the customer. AWS handles what we call the security of the cloud. Generally speaking, the hardware, the networking, the core software, the facilities. The customer responsibility depends a little bit on the specific services that you use and configure, but it generally includes things like the host OS on an EC2 instance, application software, and then relevant for us today, the specific security controls you might use, such as identity and access management or network access controls. At AWS, we have a group called the Automated Reasoning Group, ARG. They call themselves ARG, and yes, on Talk Like a Pirate Day, they all run around and go, ARG! Automated reasoning is the application of math to computer programs to provide additional security assurance. We're not going to do any math. There's no quizzes. Everybody take a breath. What the ARG does is they build semantic models of parts of our infrastructure and parts of our software. A semantic model, and we'll talk a little bit more about what that is and how it differentiates from kind of a traditional syntactic model. But with a semantic model, with a mathematical model of this underlying infrastructure and software, we can start to prove properties about the behavior of that infrastructure and of that software, which gives us a much higher level of assurance of what kinds of things can happen, what kinds of things should happen, and what kinds of things will happen. We can also compute these things very efficiently, which means we can take some problems that may look like they're intractable and make them tractable, make them computable. Talk a little bit about what I mean. So one of the technologies you're going to hear about today is called TIROS. TIROS uses automated reasoning to answer network reachability questions. So for example, you can ask TIROS, are any of my EC2 instances reachable from the internet? And to answer that question, TIROS doesn't send out packets. TIROS uses one of these semantic models of networking. So what do I mean by semantic? It does not simply look, for example, at a security group, at the list of IP addresses, and see if you've got a 0.0.0 in there. TIROS has a mathematical model of internet gateways, of security groups, of VPCs, of peering, of ELBs, and it actually generates a proof to decide if there is a path from each or whichever instances you're querying through the network out to something that can reach the internet. Another technology you're going to hear about today is we call Zelkova. Zelkova uses, say it with me now, automated reasoning to look at IAM permissions, identity and access managed permissions. Zelkova has one particular superpower. You can give it any 2 IAM policies, and it will tell you which of those is less permissive or more permissive. It will tell you if they're equivalent. It will tell you if they're not comparable. Again, it does this not by simply comparing the principal in one and the principal in the other and deciding if there's a star in one. It actually has a mathematical model of almost all of the actions in IAM, the services, the actions, the conditions keys. For those of you who have written an IAM policy, you know there's a very complex set of logic that can go on there. With that capability, with that superpower, One of the key ways we use Zelkova is we write what we call a probe policy, also sometimes called a benchmark policy, and we describe a behavior that we're interested in. We write a policy that allows the thing that we don't want to happen. Don't worry, you're going to see an example. We describe the thing that we don't want to happen, and then we can ask, are there other policies that are equivalent to that? So you're actually probably using Zelkova today. If you use S3, if you ever look at the console in S3, there is occasionally, hopefully only if you intended it, a little orange button that shows up that tells you that your bucket is publicly accessible, that it is open to anybody to read it. That little orange light comes on because of a Zelkova call. We wrote a policy that says this is a policy that allows the entire world to access this bucket. And then what we do is we use Zelkova to compare your bucket policy to that policy. And if your policy is equivalent, or if it's more permissive than that policy, then we turn that little light on to tell you that somehow or another, you might have a simple policy, it might be a very complex policy, that bucket is now publicly accessible. Zelkova actually appears in a few other places behind the scenes in some of our services. It's used in Amazon Macy. It's used in config. TIROS, so far you won't really see it in any of the services, but we're hoping in not too long you'll get an opportunity to see that. So before I turn this over to Tim and Greg, one more note. I've been very deliberate about using these words, this word technology, when we talk about TIROS and Zelkova. They are not today Amazon services. There is not a publicly accessible API. They are technologies, as I said, that we originally developed to help us secure our responsibility for the cloud, to help the security of the cloud. And we have started to find ways to introduce them as features and as capabilities inside of some of our services for customer value. We're trying to find ways to make them more accessible. One trick is, while they're scalable and very robust, they're not always the friendliest tools to use. Those TIROS queries I mentioned about network accessibility, they have to be written today in a form of first-order predicate logic, which I suspect most of us never learned, or if we did learn it, we probably forgot it. But we're always looking for new ways to put these tools into customers' hands and see where the value really is. And one way we're doing that is through professional services. So we took a team of folks, really trained them on the background of this, teamed up with the ARG to train them on the background of these tools, on the background of these formal methods. And we're working with customers that have passion not just about security, but around some of these advanced methods, customers that want to invest some of their own resources in understanding what these methods and tools and technologies could do for them and their security. That brings us to our work with Bridgewater. We've been lucky enough to work with them in their work on TIROS and Zelkova. We've partnered with them both through the ARG and through professional services. They're going to describe their work in taking those tools and some other things they've done in an automation framework, looking at threat models and security and compliance. Some of the work we help them with, a lot of the work they've gone and built on their own. We're really lucky to have them here to talk about this. And I'm personally thrilled to introduce Tim Kropp and Greg Frescador from Bridgewater Associates. Get him, bud.
Good afternoon, everyone. I see a lot of friendly faces out in the audience. It's good to see a lot of you. I'm going to get the clicker going, and we're going to get into it. Neil talked a little bit about this already, so I'm not going to get into it too much. Access and authorization controls, you're going to see where TIROS and Zelkova fall within those in the shared security responsibility. I'll talk a little bit about what Bridgewater does. We're the world's largest hedge fund. Our goal is to build great portfolios for our customers, clients. This includes 350 of the largest global institutional investors. We use AWS, and we use AWS in a fleet of accounts in order to be able to systemize our understanding of the economy. We've been working with the automated reasoning group for the past several months. These tools can be used to identify and reduce risk in your environment. Basically, we're trying to ensure that the security controls and requirements that you're trying to solicit and also work with your developers in your organization can be codified so that those control objectives are provable. Zelkova came up already. We're going to talk about it shortly. In 2017, in the Security State of the Union, you probably heard about Zelkova a little bit if you paid attention to that one from the CISO, Steve Schmidt. So in front of you is a bit of a monolithic three-tier web app. And I'm just going to use this pattern to try to describe a little bit about what our problem space is. So this is a very familiar and public pattern. You can find a lot of these types of patterns on Amazon's website for VPCs and peering and other things. Even more modern serverless and microservices architectures are available too. What we want to do here is we want to try to attest to the security and control objectives of this type of model. We're not going to be doing this. We're going to be doing this. And it's not so easy, but if you can try to work across your governance, risk, and compliance teams with your developers, as well as your security engineers, come together and codify those rules and then enable them inside of a CI/CD pipeline, then you're really starting to get to business. So if you take a little closer look at that web application pattern, you can basically take it and break it down into 3 sections or zones. A lot of you have seen something like this, and what we're going to do in the next several slides is we're going to get into what are some of the IAM constructs and what are some of the network communication constructs that Zelkova and TIROS will help you validate. On that picture, you see that there's an attacker and there's an S3 bucket. And there's also some reachability in terms of the X's. And what we're trying to do is we're trying to do 2 things. One, validate that that attacker basically we can't have data exfiltrated out, and also understand the transitive reachability across all of those different zones to ask questions about it and come to answers. Is my instance reachable? Where these tools fall, you can see that TIROS is around the VPC constructs, and that Zelkova is going to be around the authorization constructs of this particular model. I'm going to turn it over to Greg. I'm going to talk to you a little bit about what model-based verification is.
Cool, man. Thanks, Tim. Hello, everyone. My name is Greg Frescador. I'm a security architect at Bridgewater. I work on designing and building the type of verification systems that we're about to talk about. I come here from Colorado via Connecticut, and I bought this hat. I thought it'd be kind of cool to do the talk in, and then all my team members told me, whatever you do, don't wear this on the subway on the way in. And so I just put it on. Okay, so we're going to talk about model-based verification. What do we mean by model-based verification? Model-based verification is when we're trying to analyze static models of security controls in order to determine whether or not they're doing what we think they're doing. In the particular case of TIROS and Zelkova, Amazon builds the tools that build the models for us. We tweak the models, and then we build the queries. So Amazon builds the tools, allows us to build the models, and then we build the queries that analyze the models. By doing this, what we're hoping to achieve is to get a kind of provable security out of our systems. By provable security, I don't mean that what we get out is like infallible security. Instead, what we're trying to get out is a formal analysis, methodical way that we have gone about and verified that the security controls we've put into place, that they're working the way we think they're working, and we haven't just done like ad hoc probing of things. Okay, so you probably recognize this slide. This is the famous crossing the chasm slide. Why are we here? I mean, Neil and the Amazon team, they build TIROS and Zelkova. Why are Tim and I up here talking about it? And the reason we're talking about it is because we find them incredibly useful but they're not generally available. Like Neil was already talking about, they're not official Amazon services, and so the reason that we're up here is because we're trying to push TIROS and Zelkova across that chasm. We're like early adopters. Hopefully some of you guys are going to be early adopters or maybe part of the early majority, and we can get these tools into general availability. Okay, this is the kind of use cases that we use ARG for. There's a couple of them here. The first one is kind of like a real simple use case. We can use the TIROS and Zelkova tools to verify individual security controls. So if we, for example, put a bucket policy on S3 bucket, how do we know we didn't make like some kind of little syntax error or put a star where we didn't want it and the bucket's too permissive? Zelkova can tell us things like that. So we use them basically to do point-wise verification of security controls. But more importantly, the tools can be used to create benchmarks against security controls. You can create a suite of queries and TIROS queries and Zelkova queries. And what they'll do is they'll verify for you whether or not your AWS infrastructure meets all these requirements. And so that's a very important use of them, is to help create these benchmarks that verify security controls. Another really important use, especially of TIROS, is that it can locate the relevant security controls in your account. A lot of times you'll have like policies on buckets that you don't care about, right? You have some like bucket that's just holding junk, and you got some bucket that's holding valuable data. If they're in like the same account, maybe we only want to do the verification on the bucket that's holding the valuable data. How do you know where that is? Well, things like TIROS you can create a query that goes out and hunts down where the valuable buckets are, and so we're actually going to see a little bit about that later. Of course, right now, as kind of Neil was alluding to, the tools are in very raw state. They're like just either CLIs or API calls, the best way you can use them. But even in that state, they allow us to do automate the verification that I'm talking about. So basically, you can install them into a framework and apply those benchmarks I was talking about, apply them in mass. And a very important thing about the tools is that you can verify things during the design stage. One things that we would really like to do is we would like to be able to do the verification before we've made a change to the AWS infrastructure so that we can find out whether so before we put a vulnerability into the account, right, we want to prune it out early and find out if the security control is what we want, rather than say put it into play and then find out later, oh yeah, there's this, you got this bucket that's open to the world or something. Okay, so when I talk about security controls, I'm talking about things that are meant to mitigate risk. So what kinds of risk are we talking about? This is kind of like a financial-oriented talk, right, where a lot of folks in here are probably familiar with the problems of data exfiltration. If you're not, there's kind of like this cool book, Flash Boys, kind of shows you the impact of data exfiltration. When I talk about data exfiltration, what I mean is an unauthorized person or some software is going to get access to some sensitive data that we don't want them to have access to, and they copy it or transfer it somehow to some insecure place. And a real trivial model of that would be like you got this S3 bucket, they gain access to S3 bucket, they copy it to their S3 bucket. That would be a kind of like a good example. We're going to kind of use this model of data exfiltration to motivate several of the examples that I'm going to do here in a few minutes. So our security objective here is to stop exfiltration via AWS, and I need some security controls, and these are the type of conceptual controls that we're going to verify with TIROS and Zelkova. So we'll look at a couple of them. I mean, one particular control is maybe I want to put a restrict S3 bucket access. I'm going to put a bucket policy on my S3 buckets. It's going to say something about only authorized parties are allowed to access these S3 buckets. Maybe I want to limit the principals, the IAM users and roles that can access my S3 buckets. That would be something else that would be very valuable to put in place. I don't want data exfiltration to happen. An easy way that data exfiltration can happen is someone SSHs into an instance that has access to your buckets, and they suck out all the data through the SSH channel. So I'd like to put a control in place maybe to block that. in a minute, actually, if you were in the previous talk was about VPC endpoints and a direct connect. So maybe a good way to prevent exfiltration is to put in place a VPC endpoint that restricts where my instances can communicate, where they can communicate with. And so that would be another security control, and probably one of the most important security controls is the control that prevents people from disabling the controls. All right, so we want to prevent that kind of thing. Okay, so now I'm going to go through some examples, kind of look at what those were kind of conceptual. Let's look at some specific alternatives here. So we have this S3 bucket. I've got this EC2 instance. Maybe what I'll do is I'll worry about an attacker. The attacker is, say, was trying to get and put objects from my S3 bucket into some foreign bucket that's outside of our account. All right, so a reasonable thing to want to do here is to surround my bucket and my instances with a bucket policy and maybe an IAM policy. And the idea, right, is the bucket policy would have basically a principal statement on it. If you're not familiar with that, we'll go through it in a second. We'll have a principal statement on it that says, hey, only the IAM role that instance is going to run as. That's the only thing that has access to this particular bucket. So that would be like one control that I would say I would put into place. But that's not the only way I can get data. I can exfiltrate data, right? Another way I could exfiltrate data, as kind of alluding to earlier, is I could stick in place an SSH, I could try to SSH into an instance that has access to the data. And then what I'll do is I'll pull all the data out of your bucket via the instance. And so I'll put in place another security control for that. In this case, right, I'm going to put in place a network access control or a security group that's going to restrict SSH access to my instance. So now my outside intruder can't get access to the instance. Hopefully that works, and that's why we have TIROS and Zelkova to help us verify that. And then an even more complicated attack is this one. We worry about this a lot. This is a malicious package somehow gets inserted into my instance. Maybe it's like some polluted NPM library or something, where the library has been designed so that if it gets into the organization, it exfiltrates data or credentials out of the starred instance and sends it somewhere else. So that's another type of attack that we'd like to get rid of. And a way that we could get rid of that, right, is we could put in place that VPC endpoint that I was talking about earlier. And we'll configure up the VPC endpoint with an endpoint policy, and then we'll stick the instance in some private subnets, and we'll configure up the routing so that the instance doesn't have access to S3 except through the endpoint. I don't know about you, but I'm like getting like lost to how much stuff up there to verify. I mean, we've got bucket policies. We got routes that have to be right. We've got private subnets. Oh man, there's a lot of stuff. And so this is the kind of thing that we want to use TIROS and Zelkova to help us automate whether or not when we put something into place, is it actually working the way we intended it to work? Okay, so what we're doing here is dividing the controls that I just showed you in kind of like into two general families. Now there are other systems at Amazon that handle other controls, so we're not going to talk about it. We're just talking about the TIROS and Zelkova type controls today. We'll put them into two general buckets: the access control controls that determine whether or not I can actually reach an instance, and the authorization controls that are checked by Zelkova that determine whether or not the permissions are right. Okay, so TIROS is going to check the access control controls, like those, like basically routing and security groups and network ACLs, and then we're going to use Zelkova to check all those policies and principles and actions and resources and those kinds of things. So that's the general strategy that we're talking about here. Okay, so this is kind of what a kind of good process looks like for verifying security controls. I'm going to show you a better one in a second. But the basic idea is looking at the center of the slide first and working top down. You have some threat modeling process. When you're deploying a new application into AWS, you'll create a threat modeling, you'll have a threat modeling process, and that will identify what your security objectives are. That's the thing about like a stop exfiltration. So stop exfiltration, that would be the objective that comes out of threat modeling. what we're proposing is that in addition to the security objective, the threat modeling also identifies the validation rules, the TIROS and Zelkova validation rules that are going to check the control that I'm proposing. So if I'm going to propose a control that's going to stop exfiltration, I'm going to propose some TIROS and Zelkova rules that are going to verify that exfiltration. And then at the bottom center, what's going to happen is the TIROS and Zelkova automation, the rules, the benchmarks, are going to get deployed in an automated way so that every time a configuration change happens from the left-hand side, whenever a configuration change happens, that change event, which might come in through like a CloudWatch event or through a AWS config rule, that change event is going to trigger the verification using TIROS and Zelkova that's going to tell me whether or not the AWS account has been modified in a way that broke what my security control requirement was. And then if it did, there'll be a remediation step that will put the AWS account back into play. So the idea is create some benchmarks. The benchmarks are written in TIROS and Zelkova. When a change happens, we run the benchmarks. The benchmarks sometimes have findings. We fix the findings. It's okay. When I say apply here, I'm going to come back to this in a minute. I need to talk about this just for a second. I'm talking about, we like to apply changes to an AWS account in an automated way as opposed to just going through the AWS console. So it's helpful if there is an automated tool like Terraform. Terraform is like a more abstract open source version of CloudFormation. So if you're not familiar with Terraform, think of CloudFormation. But the idea is it's a domain-specific language in which I can write document a change I'm going to make to AWS. Okay, so that's kind of like what good looks like. This is what I really want. All right, this is, what's happened here is if you concentrate on the relationship between the apply arrow and the verification step, in this slide, the verification has happened before I've done the apply. So what's happened is same threat modeling, same TIROS and Zelkova controls, same automated set of queries that I'm going to test the controls with, except this time, the configuration change is going to generate a plan. And the plan is, in this case, it's going to be a Terraform plan. And the Terraform plan is verified by TIROS and Zelkova prior to pushing the policies and the changes into AWS. And now, if there are any findings, what happens is we remediate the change to the Terraform plan prior to doing a Terraform apply that pushes it into AWS. So this is kind of like what at least the ideal world looks like to us. Okay, so this is the job that we have. We have these controls. Those are the same controls I had from earlier, basically S3 bucket policy, IAM policies, and network access control stuff. Divide them up into two categories, write two sets of verification rules, and then apply them in some kind of automated way. So that's what we're going to kind of work through now, and we're going to start by looking at Zelkova. All right, so Zelkova is going to validate the authorization controls. All right, let's briefly go over what Zelkova is really about. So Zelkova, as Neil kind of alluded to already, right? Zelkova has, one of its main use cases is that it takes two AWS policies and it compares them against each other, and it gives you a kind of a statement as to whether or not the policies are identical to each other or less permissive. That's one of the ways you can use Zelkova. Another way you can use Zelkova is it can be used to compare sections of AWS policies. So for example, instead of comparing a whole policy together, we could, for example, look at just the resource section and see if the resource section is more permissive than, say, another policy. Although that is a nice feature of Zelkova, we're not going to be using it today. All right. It happens to be the case that we did an AWS Loft Talk in New York City last month. If you're interested in that, get with me. That being able to do this kind of targeted use of Zelkova, we described it, and their slides are publicly available for that. But it is one of the nice powers of Zelkova. One more thing. And we can also use it to find the particular principles or resources or actions that meet a policy. In other words, it can tell you things like, if you have a policy that says like a bunch of principals are allowed access, which principles specifically, which IAM users. Zelkova can be used to actually identify specific IAM users that are acceptable to the policy. And we're also not going to be using that feature today. But these are kind of like the general capabilities of Zelkova. Zelkova has a very basic API. By the way, like Neil said, it's not really an Amazon service, but I access it like a service, okay? It is a technology, you call it through an API, and this is literally what it returns to me. You get a statement as to whether the two policies, you pass them in as JSON, there are two JSON policies that go in, and it returns a verdict as to whether or not the policies are equivalent to each other, more or less permissive, or incomparable. The way that you use policies to verify the security controls that I was just like talking about a minute ago is we take the policy that we want to test. I want to pause just for a second. We're going to take the policy that we want to test, and we're going to compare it against a benchmark policy. But that means that we have to have enough information in order to be able to understand these policies. So we're going to do a quick little policy review here. For those who are not familiar with AWS policies, or everyone who forgot, this is your chance. This is an example, AWS policy. Basically what it says is that, hey, it's written in JSON. There's an allow statement. There could be a deny statement. The idea is that the allow or deny what follows is declared inside of the policy. Then we list a principal. The principal is the user or the role or the group that is going to be allowed or denied the particular access that we're talking about. So in this particular case, I've got a role up there called EC2 roles. That's the thing that's going to be allowed some access. There's an action. In this case, getting an object from an S3 bucket. That's the action that the principal EC2 role is going to be allowed in this particular case. It can get an object from the bucket. And then the actions, all of these things that I'm talking about in a real AWS policy, usually you can put wildcards in here that allow a bunch of things, and usually those wildcards are usually the source of trouble, right? Which you'll be tempted to stick an asterisk in there to make things easy, and you'll over-permit something, and that's usually the cause of why some buckets go globally accessible. So, so the action can have like wildcards. You can also put arrays in from any of these statements. We won't be doing that today. And finally, there is the identification of the particular bucket that we're going to allow access to. So that's kind of like the kind of tutorial of AWS policies. Any questions? No? Okay. There will be a test. Okay, so now how are we going to use this? Well, the idea is that we're going to create a candidate bucket policy. This is the control that we're going to put in place to stop that, that outsider from, say, getting access to my private S3 bucket maybe that I don't want them to exfiltrate data from. So I say I'm going to write this particular policy here, and I write it down. I'm about to push it out with Terraform. And how do I know that this thing is really what I want? Well, we're going to ask Zelkova to look at it for us. And the way we do that is that we create on the right-hand side a benchmark policy. The benchmark policy describes the maximum set of permissions that we would like instances in this particular account to have access to S3. And we declare in it things like, okay, well, we want the left policy to be no more permissive than the right policy. And the right policy says, well, allow things from the EC2 role, we'll allow get object list bucket and list all my bucket actions, and there's the bucket resources. I'll compare it using Zelkova to the policy on the left, and Zelkova will give me a verdict, and hopefully that verdict will say the policy on the left is less permissive or equivalent to the policy on the right. So what do you think? How many people want to vote less permissive? Couple? Zelkova says more permissive. Okay, so this isn't actually, like I said, Zelkova is a very basic API. It has no GUI interface, right? So we're looking at VI here. All right, so basically what's happened here is you send these two policies into Zelkova, it produces a verdict. It turns out that the reason why the policy on the left side is more permissive is that I got a little lazy there and I stuck an asterisk in for those, basically list stuff. And on the right-hand side, I only allowed you to list buckets and list all my buckets. And there's other things that you can list. There's like list versions and list other junk. And the idea is that that kind of mistake, it's very common. Zelkova catches it and tells us, oh no, your policy you wrote, that's more permissive. So this would be an example of a policy that we would reject. Okay, so let's try to fix it. So now I've fixed it. All right, I've gone and if you look at the action on the left-hand side, I just stuck in list bucket there. On the right-hand side, I also made another change over there on the principle of the benchmark policy. I stuck in an asterisk for the role. Instead of the EC2 role, I just stuck in an asterisk. That's probably something I'd really do in real life. What that's saying is, I want any role in that account. By the way, the account numbers and all the IDs you'll see today are all fictitious, so don't try to go use them. That account number, I want to allow any role within that account to be able to access my bucket. Now I've kind of fixed it all up. What do you think? Less permissive, more permissive? Zelkova says, oh, Zelkova says what? What did it say? Where did it go? Less permissive. Okay, well, the reason, I already advanced to the answer slide. Okay, it's less permissive. The reason why is because I've already taken out the list star, so that's okay. And also, on the principal section, the asterisk in the EC2 role on the right, the asterisk on the right is more permissive than the EC2 role on the left, so the left is actually less permissive. Okay, so that's an example of that. And we have another policy. I'll make one more change. In this particular case, what I've done is I've changed the principal. What do you think? Okay, in this particular case, this is an example of an incomparable policy. And the reason why the policy is incomparable is because on the left-hand side, the left policy is actually less permissive with respect to actions because it has less actions. But unfortunately, it is also more permissive with respect to the principals because it's got that asterisk up there instead of the EC2 user. This is what, when Zelkova returns this, it gives us an incomparable result. As far as we're concerned, incomparable means fail. Okay, so when I get an incomparable policy, that's not like blocker, that means fail. The policy on the left is not less permissive or equivalent to the policy on the right, so this would be rejected and not deployed. It turns out that you can use Zelkova in ways that can identify the specific sections that are less and more permissive. I kind of was talking about that AWS loft talk, but we're not going to do that today. But that's the kind of thing that we would do with Zelkova. Okay, so now what we would do is we would put the tests that I just described, we put them into a framework, and then every time before we were to deploy a policy, say a VPC endpoint policy, or an IAM user policy, or an S3 bucket policy, Zelkova knows about just about every type of policy. Before we were to put one of those into place and deploy it into an AWS account, we would run it through a suite of benchmark tests where the benchmarks are benchmark policies, and we would get a verdict as to whether or not they're less permissive or more permissive. But that doesn't actually get us everything we want, right? Now we have this problem of, we have all these network controls, right? Zelkova doesn't work at all with the network controls. It only works with policies. So this is where we're going to use the TIROS tool. Okay, I got the bounce button here, man. Yeah. Okay, these are the common TIROS use cases. All right, now, TIROS has a much larger kind of usability interface than Zelkova does. Zelkova just has this kind of thing where, less permissive, two policies, what compare the two against each other. TIROS has a kind of like a query language, and you can ask a lot of different types of queries. And I can't go through them all today, so what we're going to do is we're only going to look at these two general categories, but they're really useful categories. The idea is that we can ask TIROS, hey, I've got this instance or an elastic network interface in my account, And I want to know, can anything from the outside world get to this thing? Can any IP address reach it? Can another ENI that's in an instance in another account, can it reach it? Can this particular IP address, can that reach it? And if so, TIROS will give you a verdict as to whether or not it's reachable or not. And it also does the converse. You can identify an instance or an elastic network interface in your account and ask TIROS, hey, can this thing get to the outside world? Can it take the data in my S3 bucket and push it out to, Bob's bucket? So you can ask TIROS to give you that type of verdict too. Now it can also answer lots more questions besides those two, but we're going to restrict it to this particular case. Okay, this is an example of what a TIROS query looks like. This is a language called TQL, TIROS query language. The basic idea here is that uppercase parameters, variable names, those are uppercase identifiers are variable names. And what TIROS does is, when you pose it a query, it gives you back a set of bindings that satisfy that query. So with the type of data that you give it, which I'll talk about in a second. But in this particular case, right, I've asked it the query, give me instance has subnet, and it returns me all the instance subnet pairs where the instance is in that subnet. Now, if that's kind of like what are you talking about? This may help. It's not, I want to be clear here, there's nothing to do with SQL in TIROS. But to give you a little bit of understanding about how the query works, it's as if you were writing this type of statement. Basically, you select the instance in the subnet from AWS where the instance have subnet predicate is true. And it returns to me that basically table of pairs. You can also ask, it has a huge library of these predicates, like instance has subnet is one of the predicates that's in the library. Another one is this kind of interesting one, internet can SSH to instance. And what that does is it returns you a set of instances in your account that can be reached via SSH from the internet. And it does not do the following, okay? It does not just check to see whether or not the instance has like a security group that has like the port 22 open. It does much more than that, and we'll kind of talk about it in a minute. But it has this kind of library. All right, well, there's that bounce again. Okay, these are, I mentioned there's a lot of different type of queries that TIROS supports. This is the list of data types that TIROS supports. It's basically all your networking constructs in AWS. Some particular ones that are really helpful are that VPC endpoint one, the route tables, those are very helpful. VPC peering, also very helpful. Okay, so now let's try to get to validate some security controls that have to do with networking with TIROS. So remember I had that control from before. I want to block SSH access into my S3, into an instance that has S3 access. So one way I could do that, right, is I could ask TIROS the question, well, can the internet SSH into an instance and give me the set of instances that the internet can SSH into? And TIROS would return to me something that looks like this, okay? So I'm looking at that diagram on the right, and I'm getting back an answer that kind of looks like this. Let's pretend for a second that XYZZY was the instance ID of the starred instance, okay? So TIROS would give me this answer back, and what I would do is I would look at that result set, and I would say, is my XYZZY instance in that set? And it is, okay? So in this particular case, right, it's vulnerable. But what really not so great here is that I have to actually know the instance ID that I'm looking for in the TIROS results in order to see whether or not it's in there. We can do a lot better than that with TIROS. What we can do with TIROS is we can basically create our own custom rules. And what this rule is doing is it's looking at the configuration of our data, and it's saying, let me go find all the instances that are in the data zone, where the data zone is defined as the instances that have access to the S3 buckets through the VPC endpoint. So this is essentially saying, I'm only interested in checking things regarding instances in the data zone, and those are the ones that have access to my data. And now I can call that rule, that defined rule, just like I could call the TIROS built-in rules, and it'll return to me now all the instances that are accessible through that VPC endpoint. Now, okay, I'll get them back, right? Now, if I combine that with the internet has SSH access that I showed you before, now we get kind of like the beginnings of, you can see beginnings of a benchmark here. I call, give me all the things that are in the data zone, and I combine it with a call to, can that thing be reached from the internet via SSH? And now, if I get an answer to this, I know that that instance was something that had access to my data, and for some reason, it's accessible via the internet. At this point, I think it's important to point out what do we mean now by the internet can SSH to the instance. TIROS has basically a model internally of how networking works. Internet can SSH to instance means things like you've got like an internet gateway, and you've got basically the absence of a blocking network access control, the absence of a blocking security group. You've got routing to the instance. It does, if all those things are true, right, and there's nothing blocking port 22, then the internet can SSH to your instance. What TIROS does not check, TIROS does not check whether or not there is actually an SSH daemon running on the instance, and it does not check whether or not the SSH daemon has an account that the attacker could actually log into. So what we're doing is we're looking kind of like at the surface area of the instance. But with respect to what I just said, though, TIROS can tell whether or not that instance is reachable from the internet. If I get back nothing, you're good. If you get back something, bad. At this point, it's kind of obvious how you can create an automated test suite out of this kind of thing. So let's move on for a second. Just being able to SSH into an instance, that's not like the only thing I'm interested in. I'd also like to be able to see whether or not I can get to an instance from some other port besides SSH. Well, TIROS can do that too. There's another predicate, it's got a very complicated name, reachable public TCP UDP. Yeah, okay. The idea is we specify, hey, we want ingress direction, that means from the outside in. Protocol 6 happens to be the TCP/IP protocol. Elastic Network Interface is attached to that instance. What I'm basically doing here is I'm saying, okay, I want to be able to verify my control if anyone can reach this instance over a TCP protocol as opposed to just SSH. And now I can create a compliance rule that kind of looks like this. Okay, this is a more complicated one. In this particular case, maybe an attacker is not just looking to find an instance that has direct access to my data. Maybe they can find an instance that has like indirect access. We're kind of like looking for the weakest link kind of thing here. All right, so in this particular case, what I'm looking for is an instance that I can reach via SSH, but that instance is, that instance can SSH to my instance, and I can reach that instance via TCP/IP. So I could basically have an attacker that can reach the blank instance via some TCP/IP port, and then that instance could be compromised to SSH into the instance that actually has access to the data. And now I can check for this kind of like transitive type property. At this point, right, you should say like, how many levels of indirection do you want to go here? Well, it turns out you can actually go pretty darn far because there's a transitive predicate called can SSH Tunnel. TIROS has, basically what can SSH Tunnel is, it's a predicate in TIROS that allows me to check whether or not an instance can SSH to an instance that can SSH to an instance that can SSH to an instance that can get to your data. So now what I do is I write a compliance rule that says, I don't want any instance that has transitive SSH access to my data to be reachable from the internet, and that's what this particular rule does. All right, so now the idea is that we're going to create this benchmark library of TIROS rules, TIROS definitions. And the way they came about is we did threat modeling on the application, and then as a result of the threat modeling, we identify some security controls, and those security controls, we write validation rules. In this case, the validation rules are like these TIROS definitions. We write these TIROS definitions, and now we put them into play using automation. I was alluding earlier to what we would like to do is we'd like to deploy them, we'd like to run this automation prior to actually pushing changes into AWS. And the way we can do it is to follow a workflow that kind of works like this. So in the top center there, the orange box, this is like a Git plus Garrett system. Like Garrett is a workflow management tool. It's an open source tool that wraps around Git. Git is, of course, a source code control tool that probably most people are familiar with. The Terraform, remember that Terraform I was talking about? One of the advantages of Terraform is it is a declarative, descriptive set of changes I'm going to make. So what we're going to do is we're going to treat the Terraform as if it is like source code. All right, so we treat the Terraform, because it is source code, right? It's source code, it's going to make a change to our AWS account. So we treat it like source code, and then what happens is, every time a configuration change happens, the developer who's making the change pushes, git commits, the source code, the Terraform, into Garrett, into a development branch. So it goes into a development branch of Git, and then an automation, a piece of automation, pulls the code from the development branch and applies those Zelkova and TIROS checks that we were talking about. It applies them in an automated way. If the checks pass, then what happens is the automation pushes the Terraform back into the production branch of Git and Garrett, where some later automation pulls it into Terraform and deploys it in AWS. So now the only thing that reaches AWS is things that have actually passed the Zelkova and TIROS benchmarks. On the other hand, if we have a failure, then what happens is it creates a set of findings that go back in as Garrett comments. You don't have to use Garrett that way, but that would be like one way to do it. You could use Garrett comments, and the developer has to remediate the problem to get out of the vicious cycle on the left-hand side until they get everything fixed, and then eventually it gets promoted into the production branch. So that's basically how we could use TIROS and Zelkova to kind of create an automated approval workflow. Okay, so what I've talked about today, right, as I talked about basically how we use TIROS to verify network access controls and build like libraries of TIROS definitions. TIROS is not, unfortunately, generally available yet, but hopefully it will be soon, and will generate some enthusiasm. Zelkova is used to verify policies and permissions, and I'm going to turn it back to Tim to close us out.
Check. Isn't Greg great? So thank you very much, guys, for attending and listening. The inspiration that came around for today's talk is really around demystifying this material a little bit, getting your heads wrapped around it. It's a little bit difficult if you haven't been accustomed to thinking in this way. And what I mean by thinking in this way, I mean as a compliance or a security professional, there's years of built-up thought process that we have that kind of comes with our territory. The financial services industry as a whole, if you go back to some of the previous AWS talks, is driving adoption of this type of formal logic to achieve what is called provable security. And we're trying to do it in this way. And just as a curiosity, I'm going to look at the audience. How many people would like to have this at their organizations? All right, so Amazon, there's your demand for GA. So I would like just to go back over what did we talk to you guys about, right? We talked about model-based verification in Amazon. I mentioned reInvent once. I'm going to mention it again. There's an actual SID326. Look that one up. Zelkova was mentioned on that. It's for provable security and guardrailing. Another one that's really relevant to look at is security anti-patterns. If you're interested in to see what other organizations are considering anti-patterns, that one's with Kurt Gray. That's FSI304. So we're trying to come up with common patterns that are well known. We use threat modeling, which is a very generic thing a lot of people are accustomed to. Who can do what, resulting in badness? We develop those rules based on that threat modeling. We're trying to make sure that this is demystified for people, for folks that want to know more about it. Please come speak to us afterwards. And of course, we're looking to have these be like bookends so that we can do them in pre-deployment checks and post-deployment checks. And that's about it, folks. I'm going to turn it over to Neil, and we're going to have some Q&A for you guys. Thank you very much.
If folks have questions, particularly for for Tim and for Greg, we've got a real opportunity here to have these folks here on stage. If you have questions about how they're using this, the threat modeling, any parts, appreciate you. There's 2 microphones, one at that end, one at this end. Please come up and just ask, and we've got a few minutes for maybe a couple of questions if folks have them.
Hey, so it makes sense, the Zelkova part makes sense for the compare because it's doing 2 files, right, on the local file system. For the TIROS compare, how are you doing it in development if you haven't deployed something? I'm assuming TIROS is like using API calls to investigate what's actually deployed, right? So
Yes.
how are you doing that static check before you actually do the
I'll let Greg take that one.
Does that make
Yeah,
sense?
yeah.
Thanks.
So TIROS has 2 different ways that it can acquire the data that it is that you're creating the query. One thing is it obviously queries the live account, but another way is that they have a snapshot feature, and what the snapshot feature does is you target an account and it grabs a snapshot of that data, and then what you can do is you grab the snapshot and you can the snapshot has a model. You alter the model according to what change you're going to make, and then you can ask TIROS to answer the query with respect to the altered model, and then it will give you an answer.
Okay, and that model is just like a JSON document?
It is encoded in JSON. There's some semantics. So there's like different JSON stanzas. It is in JSON right now. Okay,
so
it is in
you just,
JSON,
like,
and there's meaning to the different stanzas. And I don't know whether or not they're going to make that public,
Sure.
but it does. But it is JSON, and it does have meaning. Yeah.
Okay, and you're just stitching your change into
Yes,
that.
exactly. Yes.
Bingo.
Yeah.
Left side.
Sorry, I have 2 questions.
Right side.
I'm fairly new to this. How reliant is this stuff on Terraform, or can you do it directly on the
It's not reliant on Terraform at all. We just happen to use that for our mechanisms and others as well. So it's basically, if you think about how we're trying to do it, the feature of Terraform, which is that plan, that's more what we're interested in, right? Both the pre-deployment thing is like, what does it look like before it changes, right? And then the post-deployment, like what actually happened. So, it's conceivable you can come up with a system that's similar to that. Terraform just has that facility.
Okay, and if you wanted to start with something that was post because it's already there, you could just run this on that.
As Greg was just mentioning, right, the models in JSON.
Yeah. So to give you a specific example, you could, for example, take a CloudFormation script and make an alteration to the TIROS fetch, the fetch data that your CloudFormation said deploy this new instance, right? And then you put the new instance in the TIROS data that you feed the TIROS. You could do that.
Okay.
Instead of using Terraform.
One other quick one. From Zelkova, when you showed the example that came up as incomparable, is there any idea that you've suggested them of having tiers of what's more important than the other? Like an action failure versus a role or principal failure is sort of a different problem.
That's true.
We hadn't considered doing that. I guess it's something we can take away. Dan Peebles here is our expert on Zelkova.
There are definitely other things that you can do to compare those different sections.
Yeah.
Thank you very much.
You're welcome. Okay, left side.
We got one
Your
more.
left.
I know folks are running to other sessions. I'm just going to put in a call. Please fill out the survey. We love to hear your feedback, comments. Don't just check the boxes. Tell us what kinds of things we can make better. Last question. Go ahead.
Are you using the Terraform plan output to compare or use it to feed the TIROS CLI?
Yes, there's a public domain tool called Terraform Plan Parser, and it emits. Basically, what it does is it takes a Terraform plan and it creates a JSON out of it.
Okay.
Yes, and then we consume that JSON.
So you're using that in the workflow that you described?
Yes,
before?
exactly. Yes.
Okay.
Yeah.
Thank you.
Thank you. Thanks, everyone, for coming.
All right.